From this page one that you can see here, you see like this whole note is basically just self-explanatory. This beginning is where they're telling you the formulas. So the number of subnets, that's 2 raised to the power n, where n is the number of bits borrowed. So n is the number of bits borrowed. You see how we use that formula later. Then the number of hosts per subnet, which is 2 raised to the power h minus 2, where h is the number of host bits remaining. We subtract 2 because of the first address is the network address and the last, yeah. So this is like how they used to do it, and this is like normal thing. Two of these addresses are reserved, so for the network and the broadcast address. So as you can see here, then this block size, so block size, this is the 256. Normally when you're writing IP address, you see 255, 255, 255, but like it is 256 now is 2 raised to power 8. When they are writing IP address, for example, I'm not trying to like bring other things, but let's just take it as like that now. So 256 minus the subnet mask octet, I'll explain that later, or 2 raised to power the host bits. That one I'll show you. So from the first calculation, so after just these formulas, blah blah blah, you will see the explanation now. So how to calculate subnet max steps by step. The scenario one, we need the okay, scenario one, this is an example. Divide this IP address into 4 subnets. This 4, you see how I'll use it now. So from that, the bits, this is where you are going to use that for. When you say using 2 raised to power n, what they ask us to do is that we're dividing it. So since we're dividing it, you start like this. 2 raised to power n greater than or equals to 4. As you can see, the 4 is the is how many subnets we're splitting it into. So you are now looking for the borrowed bits, which is the n. So what you do is that you are testing until you get a value that is greater than or equals to the number. You just need, it does not matter if it is more. What you are looking for is the minimum, which is when it is 4. So here it is 2 raised to power 2 equals to 4. That, so you just take 2 as your n. So you borrow 2 bits. So what you do in the second place, you can see here, calculate new prefix, which says the one that we had before, which was /24. You're now adding 2 to it, which you now get /26. So most people don't understand this thing, but this is the subnet mask in decimal. One way to do this is that just simply say 1 2 3 4 5 6 7 8, put a dot. This 8 right here is this 255. If you try converting it, it is it. So why am I doing this? So after you are done with this 8, you now do 9 10 11 12 13 14 15 16. So that's another 8, 16, put a dot. So you are trying to reach up to this 26. After you are done with that, now that was 16 we did here, right? 17 18 19 20 21 22 23 24. So yeah, you did another 8, you put in this thing, so that's 24, but you are going up to 26, so that's 25 26. So now that you are done with this thing, normally there are 8 characters. Okay, let me continue the thing. Normally there are 8 characters in each place, so because we have 2 in this last one, you're adding zeros. You add zeros until they become 8. So that means you are basically adding 6 zeros: 1 2 4 5 6 7 8. So now there are 8. So if you convert this into decimal, you will get this 195. And another way to get that thing is that this first one represents let me do comma here. This first one represents 2, so 2 raised to power 7. So when you're only doing this first one, you do 2 raised to power 7. Then if now, since we have more, we do 2 raised to power 7 plus 2 raised to power 6. So that's basically how you do it. If you do this in your calculator, it will give you 195. 3 raised to power 7 normally is 1, I think that's 128. This right here is I think 64. So add them together, 64. If you add it together, it give you 192. So that's how they got this. Okay, so if I remember where I stopped, it was here. So if you understand what I was doing here, then next is simply find the block size. The block size now will be this number at the back. If you backtrack on how we got it, that's the just backtrack. So we have this thing as we already found out how to get it. So you simply minus it from 256, and that will give you 64. So what are you using this block size to do? You are separating into these subnets. So these are the separate places. So the first one will always be 0. This The reason why you are tampering with this one and not any other one is because of this 192 was in the last octet. These places are called octets. So this one is in the last octet. So that's why you are touching this one and not the other ones. So when you go to this, you are editing this one, you put 0 in the first one because that's how it starts. So 0, you're now going to 64, you're now going to 128, you're literally adding 64. You can do the calculation, add 64 to 64 to give you this, add another 64 to give you this. So that is this, and you can see we did it in 4 subnets as the question told us to. So we're basically done with that part. Now look below here, you see what they call scenario 2. Find the subnet size needed for 50 hosts. So now going to look at this 50 host section, find the host bits. That's the first thing you need to do. You're now going to use that other formula. The 50 hosts will be at this side, the same as the 4. So the 50 hosts will be here, and then you're not going to be testing values. So this is me basically skipping all those other ones because of 2 raised to the power 4, it will get 2 raised to the power 3 is 8, 2 raised to the power 4 is 16. So I skipped all of those ones and you go to something that is close. 2 raised to the power 5 is 32, minus 2 will give you 30. This is too small. 2 raised to the power 6 is 64, minus 2 is 62. So you take this one because of it is greater than 50. So then your host bits, which is 6, because it is 6 that is up here. So then now you're going to determine this. All right, you are determining the prefix. You are using this 32 because of, let's go back a bit so that I can show you guys why exactly we're using this 32. If you count this, every character, that's 8 characters here, 8 characters here, 8 characters here, 8 characters here. This is me like showing everything out. So if you multiply 8 times 3, because of 8, 8, 8, 8, if you even count them individually, everything is 32. So there are basically maximum of 32 bits, everything that is going to be here. So that's why you're using that. So this is basically like the opposite of what we did in that other section, because these host bits can also be represented as the number of zeros at the back. If you try it, I think, oh yeah, if you check right here, it's slash 26. So slash 26 is the same thing we had in the other one, so we can even use it perfectly. So let's see now, this slash 26, right? How many zeros do we have here? 1 2 3 4 5 6. 6 is the number of host bits we have. So that also proves that if you do this, you can get your host bits by simply using the number of zeros at the back, and it's as simple as that. So back to the other one, this range thing. So they gave us, oh, we're using this as like a test. So this as slash 26, we're just using it as an example right here. So the network address will be 0. The first, so network address, as I told you, oh well, I think you guys can still see. So the network address will be 0. The Because of the exact first one, remember what they told us before, is reserved, the first and the last one, which is this. The reason we're doing that is because of the number we had before. I'll explain that later. So first usable host is this. We are editing the last one. So this is the one we're changing. We start to 1, you go to 22, and then you end. The last one is now 23. So this right here is the what we do basically as clause, this table right here. So this is the prefixes. I lifted them out. This other section here is for the masks. This one here is for the block size, and this one here is for the usable hosts. So this subnet marks that is here, how you do them, if you try counting it yourself, 24, just another way to even do it is the man was telling us about finding 2 raised to power what is 24, or but simply just say 8. Just try doing it. 8 8 8 8 plus 8, that's 16, plus 8 again, that's 24. So you already know it's going to be, these first ones are going to be filled and this last one is going to be 0. So that was what we have here. So for this 25, it's going to be 888. It's going to be a 1 here. So basically 1 at the front and the other 7 zeros. So that's how you know is this. So just do 2 raised to power 7 that's there, or you can just, it's harder to convert it back into decimal, but just do 2 raised to power 7 to give you your answer, which is 128. If you also do the same thing for this as we did for the other one, you have seen this one /26 to give you the same thing. /27, you can test everything to give you the exact same answer. Another way to, let me also tell you guys that again from what I did before. Right here is what I'm talking about. Let me check my camera. Alright, so this one here, as you can see, when I'm calculating, I use this first one as 2 raised to power 7. I use this second one as 2 raised to power 6. So for these other ones that we have here, when we have this /20 /26 right here, if it's /27, this here will be a 1. That means you also add 2 raised to power 5, and you keep going, you will get your answers. So let's move on to the blocks size. So from the block size and the usable host are basically the same thing. At least they require the almost exact same with calculation. Once you have the block size, you're gonna have the usable host. So what you're gonna do is the block size here. Alright, the video cut off there. So what I was talking about is this. If you look here, this is the formula. You are literally minusing it from what you get here. So that's 256 minus 0, that's 256. If you do 128 minus 256 minus 128, which give you this. Just minus these numbers from 256 and you get this. And if you are looking at this other one, you can see a trend. Simple. This right here is for this right, so forget about this other one. So here you have 256, here you have 254. What do you see? There's a difference of 2. So you're basically going to minus that because of the reserved ones. So you're minusing 2. So you have 256 here, you have 254. You have 168, you have 128, we have 126. You have 64, you have 62, 32, 30, 16, 14, 8, 6. So you can see here, usable host block size minus 2. And how do you get the block size? From this other one. Alright, I did not talk about this, so let's go back to this now. So this is the IP address. We're using this as an example, so they can give you your own IP address and all of that. So we're focusing on this. When now we're identifying the range, remember the first one is the network address. We'll now see the usables here. Then this last one is the broadcast. So how did we get this and why these numbers? The way to know is /26, right? Remember the block size. You're looking at the block size now. Go down here, you see the block size for /26, 64. So what you're gonna do is the first one is 0. The next after that one, because the first one is reserved, so 0 is reserved. So you go 1 is the first usable, the last usable. So the range is basically this one here. First and last is here. Then this right here is the 23. So imagine now, if you want to count 1, 2, 3, 4, 5, 6, 2 all the way to 24, that will be 24, right? But here you are not starting from 1, you're starting from 0. So because you are starting from 0, you are going to say 0, 1, 2, 3. So from 0 to 23 is 24. So you can see that the range of characters is still 24. So that's why the block size is still 24. There are still 24 stuff here. So that's what I was talking about before.